Mhm. All right, let's get started. Hello, everyone. This is the March Zeal call. My name is Elena Geralt. I do product marketing at Electric Coin Company, and this is the very first Zeal call that we're actually doing through YouTube live stream. So if there's any technical difficulties that come up, please bear with us. But we have an exciting call today. There's a lot on the agenda. So maybe what we normally do for a Zoom webinar, we give people like 5 or 10 minutes to trickle in. But since this is a live stream, the dynamics are slightly different. So what I'll do is move over to our agenda. Like I said, we have a lot of ground to cover and two really amazing speakers joining us today, Yan Zhu from Brave Browser and Jay Graber, founder of Happening.net. I'll give them their due intros in just a little bit, but I want to start with welcome and announcements. So before I go on, I just want to say we've been doing these Zeal calls for over a year. They're a monthly community call where everyone in the Zcash community, whether you're an ecosystem developer, just a Zcash fan, or crypto curious, maybe you're just getting started, this monthly call is meant to be a resource for you to learn a little bit more, not just about Zcash itself, but also about freedom technology, privacy, cryptography, and other kind of broad topics from around the industry. So if this is your first Zeal call, welcome. And if you've been here before or been to a few of these, thanks for joining us on YouTube. And I hope this live stream format it allows for more engagement and this content to get to a broader audience of people. Okay, so let's talk about some quick community announcements and housekeeping items before we move on to our speakers. So a lot has happened since the last time we talked in February. We have these 5 announcements, but if you want to stay up to date with the latest and greatest happenings on Zcash, I encourage you to check out the community forum. So the Zcash community forum, I post weekly updates on there, but also different members of the Zcash community chime in and have discussions about everything from, who is the latest ecosystem partner to support Zcash to, what's going to go into the next protocol upgrade. So these are the quick announcements. One, Electric Coin Company has proposed unified addresses. There's a GitHub issue for what exactly these are, but this is an active discussion that you can join either in the forum or on the Zcash Discord channel to learn a little bit more about what unified addresses are and when they might be incorporated into Zcash. Next is ECC has also proposed a new timeline for Network Upgrade 5. So I have those links here. I'll share them in the YouTube description after we post the live stream. But those are 2 things to keep in mind if you're following the latest developments with Zcash protocol updates. Another exciting announcement is that Zondax has completed their 3rd milestone for the ledger integration. This is the 3rd of 4 milestones. So the 4th milestone is the last one, and I know it's something that shielded support on a hardware wallet is something a lot of Zcash community members have been really excited about. So we're thrilled to see that project continue to progress. And lastly, big kudos to the Zcash Foundation. They recently announced a completed audit for their implementation of Frost. So this is just one, Zeal calls are just one of Zcash's regular community calls. The other calls that we have on a monthly or biweekly basis are Gardening Club. Gardening Club is really good if you're an open source developer and you're looking at applying for grants, or maybe you want to just learn about what other developers are working on, the Gardening Club is a great call for you. And the next call is next week. We'll have Zondax and Nighthawk giving deep dive presentations on their projects. Then we also have the Arborist call, which now happens every 2 weeks. And that is the best place to find the latest and greatest discussions on Zcash core protocol upgrades. So they'll be talking about unified addresses, the updated timeline, but they also, in the Arborist call, talk about node implementations like ZebraD and Zcashd, and some other topics related to the core protocol. And then lastly, we have some really awesome speakers for April and May for the Zeal calls. For April, we have Ashkan Soltani and Robin Berjorn. They'll be talking about global privacy control, which is basically a really exciting continuation of Do Not Track. That's our 2 speakers in April. And then in May, we have Julia Angwin from the Markup. Julia Angwin is somebody I really admire. I absolutely love the Markup. So if you're interested in data journalism, holding big tech accountable, and what this really innovative nonprofit newsroom is doing, don't miss the Zeal call in May. All right, one last thing on announcements is ZOMG grants. I thought it would be helpful to just show how much activity ZOMG has been doing in the last 30 days. So there's 6 grants that they've issued that I could count, everything from cold wallets to blockchain explorers, ZEC page server costs to educational videos and outreach in Hindi specifically. So if this is interesting to you, if you're thinking about applying, again, don't miss the Gardening Club calls, and also make sure to check out the Zcash community forum. There'll be a lot of people to help you out there if you're trying to figure out the best way to apply. And now for our first guest speaker. So it's a real pleasure to introduce Yan Zhu. She is the security team lead at Brave Browser. And she's like way more than that. So Yan is a security engineer, open web standards author, and open source contributor, and also super talented musician. So you should definitely follow her on Twitter, which is where I get all my latest and greatest Yan Zhu information. But she's contributed to Brave, HTTPS Everywhere, Firefox, Tor, and many other projects. So for today's conversation, Yan is joining us to talk about existing protocols for Brave payments and other privacy-preserving payment use cases on the web. So Yan, thanks for joining us. And if you want to share your screen, I'm happy to hand over the controls to you.
Cool, thank you. So I also used to be on the Zcash Foundation board.
Oh yeah, I forgot. I should have said that.
Yeah, it was
Zcash alumna.
Yeah, it was a very brief period of my life. Cool. So yeah, it's really, really great to be back in the Zcash community doing this call. Can everyone see my screen right now?
Your screen looks great.
Okay, perfect. Cool. So thank you for that really awesome and kind introduction. I work at Brave, and many of you probably already know Brave because of the cryptocurrency community. But for anyone who doesn't, it is a web browser that has privacy as a core value and also has a built-in cryptocurrency payment system. I'm going to start by just talking about why we decided to build yet another browser, because obviously there's Chrome, there's Firefox, there's Tor, there's lots of options, and I'm sure you guys are familiar with those. Kind of a core problem for Brave is that websites are mostly funded by ads, which to most users seem like they're free, but they actually have this like high privacy cost and network cost. So before I worked at Brave and like knew anything about the ad ecosystem, I thought, you visit a website gets an ad from a third party and then serves it to you, right? Like pretty simple, just 3 parties. Turns out there's a lot more than that, as shown in this diagram. So when you go to a web page, the web page gets an ad from a supply side platform, which then goes to an ad exchange, which then goes to a demand side platform. And then there's hundreds or even thousands of bid requests coming from the people trying to show you ads, which are often targeted to you based on your personal data. And so your data actually gets sent to many parties in this whole process before you get to actually see an ad. And what's even more concerning sometimes is that the data that is being sent to these random parties is pretty identifiable or sensitive. For instance, they can infer your gender and age. Sometimes they'll even send what they believe is your like exact latitude, longitude location. And obviously there's these advertising IDs and details about your device and so forth. Not to mention that ads are just, ugly. So there's this old website called the $1 Million Homepage where someone tried to sell every single pixel on their webpage. I think this was like 10 or 20 years ago in the early days of ads. But yeah, this is kind of just a parody of like how bad this can get if you're trying to sell like all your display space. You just end up with this like very cluttered looking web page. And I think they eventually did sell all these pixels for $1 million and were able to pay off their college loans or something. So, as a result, it's not surprising. People are using ad blockers more and more. This graph only goes up to 2017, and pretty sure the trend just keeps going up since then. Right, so the goal of Brave is to repair these existing privacy problems with ads, but not completely cut content creators off from revenue, because we all know, the point of ads is that websites need to make money somehow. And without ads, like what are their options? So starting from that goal, we created this Chromium fork on desktop and in Android, and on iOS, it's a Firefox fork. The main kind of privacy innovation of Brave is we block privacy invasive ads and trackers by default, so people don't have to install any extensions. And optionally, we also have a micropayment system, which I'll get into in a bit. So if you use Brave, the main interface for the privacy aspects is called Brave Shields. I'll go through this pretty quickly. But we have this UI that shows you like number of ads blocked, number of trackers blocked. And then you can also control these on a global setting. We have HTTPS everywhere integrated, which if you're familiar with Tor browser, it's a built-in feature in there where if we know that a site can be upgraded to HTTPS, we will do that even if they don't automatically redirect to HTTPS. And we just use the same EFF rule set as Tor browser for that. Also blocks ad and trackers. Something that's kind of interesting is that many people use these Firefox or Chrome extensions for ad and tracker blocking, where trackers done, or rather the blocking's done via these web request interceptions in JavaScript, because that's what extensions are written in. But we actually were able to get a lot better performance by kind of doing it natively in Rust. So I did not work on this. I don't know the details. I just know it improved performance 69 times, which is very cool. Obviously, this breaks a lot of things. So you have options to allow Google, Facebook, Twitter, if you're okay with some tracking and just want those sites to work correctly as a third party. Another kind of interesting feature is device recognition. So people these days do not just track users via cookies because cookies are so easily blocked. Instead, they'll do what we call device fingerprinting or device recognition, where they kind of look at unique combinations of unique browser configurations and these other super cookies to create like an identifier for someone. So we kind of block some of the methods that are commonly used for this, such as the HTML5 canvas, WebGL, audio context. we used to just block these outright, but now we use this technique called farbling, where we kind of return fake randomized values for these so that the site doesn't completely break, just doesn't get any information that can be used as a long-term tracker. Also script blocking, which, if you've used NoScript, this is a familiar feature to block JavaScript. HTTPS upgrades, which I already talked about. What a lot of people ask us is, how do you actually differ from Chromium since we're a Chromium fork on desktop and Android? First off, we recognize that most people who care about privacy don't want to be tracked by Google by default. So we disable these Google services like account integration and Chrome Sync. There are some that I think are useful, such as like safe browsing, getting extensions from the Google Chrome store, spell checking CRL sets. And so these things we go to Google for, but we proxy them so that Google doesn't see your true IP address and doesn't get any cookies when these requests are made. Whoops. We also disable a bunch of Chromium features, which I won't get into now, mostly for privacy reasons. On top of that, we disable third-party cookies, and we set these lifetime limits on other cookies by default, even if they're first-party. For refer, we used to spoof these, which means like if you're on New York Times and it makes a request for an ad server, we used to change the refer from New York Times to the origin of the ad server. That turns out to have broken a bunch of websites. So we now have like a more lax policy, which is that we only send the origin if it's a cross-origin request. But it's the true origin. We no longer like spoof it. So also other web APIs we disable because of privacy concerns. And this is kind of like an ongoing discussion with the W3C about like what web features are actually worth the potential privacy or fingerprinting cost. So another feature is that often there will be a site will go through a third-party redirector. So, if you click on a link in a search result, that'll get redirected through this other domain that kind of can track users because it's a first-party redirect. So we kind of took this idea from what Apple does in Safari, and we generated a list of these domains which are used to redirect users. I don't think this is yet on by default. It's just something that we're still looking into. Also query string tracker blocking. So if you've ever shared a link from Facebook or some other popular site, you'll see that they append these IDs, which have like a long random string. And it's kind of just used to track like where a certain link was shared from, which, is good for websites doing analytics, but it doesn't really provide any benefit to users. So we filter these out. So that's kind of the whole quick run through of all the privacy, the normal web browser privacy stuff that we try to do. But I think the most interesting part of Brave is how we're trying to solve the web monetization problem. That is, block all these trackers and all these fingerprinting methods, but also not block websites' ability to generate revenue. So there's kind of three components of this. One is that we use local data mining to figure out what a user is interested in without that data ever leaving their device. We also use some cryptography, which I'll get into in a second, to allow us to do payments to users and allow users to pay websites without leaking data to us about who they're trying to pay or like what they're interested in. And we also have an incentive for users to give money to websites because although ads are off by default in Brave, if you do choose to see Brave ads, then we will give users a part of that ad revenue so that they can further contribute this money to websites that they're visiting and want to fund. So at a high level, the flow is that we have this token called the basic attention token, which is an ERC20 token, and advertisers buy ads in Brave, and then users who see those ads earn the token and use that token to reward creators. And finally, the creators earn this token, which they can later convert to fiat via our partner Uphold. So this is what it looks like in Brave. We call this system Brave Rewards. So users get BAT from either seeing ads or free BAT grants. I think they can also buy BAT with a credit card, but that's a less commonly done. So we try to make it really easy and seamless for users who aren't, interested in cryptocurrency or even have cryptocurrency wallets to get a hold of BAT. So this is kept in a one-way browser wallet, so they can't spend it except to tip publishers or auto contribute to publishers. And then for publishers, we try to get publishers onboarded at creators.brave.com. So actually, if you run a website, or even if you just have a Twitter account or GitHub account or YouTube account or Twitch, you can go to creators.brave.com and register that with us. So then we know where to give those funds if users want to, for instance, give you a tip on Twitter. So yeah, I encourage people to do that because you might already be getting tips from Brave users and not be aware of it. And once you're signed up, we consider you a verified publisher, which is someone where we know like where to give the funds to if they get a tip. And on the other side of that, so users who choose to opt into Brave Rewards can get these ads, which is how we kind of, which is how they earn money with ad revenue. So that we decided not to inject these on pages because that's kind of intrusive, and also because some publishers might say like, hey, we don't want you to replace the ads that we paid for with your own ads. So instead, it's shown as this system level notification. And this is all done locally, so no data is actually sent to the advertiser until you click an ad and actually go to their landing page. So the goal of Brave ads is that we want users to see ads which are relevant to their interests. But on the other hand, we don't want to compromise their privacy. In particular, we have two specific goals, which is that both Brave, our company, not the local browser. So Brave servers and advertisers should not be able to see what segments a user is in. So segments are like the categories of interest that a user has. So for instance, I really like rabbits, so I could be in, the rabbit segment or like the small pets interest segment. And the second goal is that if a user interacts with two ads, then we should not know that it's the same user who interacted with both of those. So basically, we can't build a profile of all of your interests by seeing what kinds of ads that you're looking at. So first of all, on the question of relevance, how do we pick which ads to show a user? So every user in a location actually downloads an entire ads catalog for their location, which gets updated, I think, a few times a day, like maybe every 6 hours or so. And then the Brave browser does local machine learning to figure out what you're interested in. So if you think of a browser, it actually has like a very perfect view into your browsing history locally, right? So like a browser knows like what web pages you're seeing, like how much time you're spending on that. And that's all information that it can use to figure out your interests locally without sending that data to any third parties. So, if you visit a lot of car websites, your browser can infer that, you're interested in buying a car and show you a car ad, but none of this data leaves your device. So basically the client then figures out your interests and then picks an ad from the local catalog, which matches those interests. And then the second goal of privacy is how do we achieve our unlinkability goals while still paying users for the ads that they are seeing? So I'm going to go through this kind of quickly because I'm low on time, but a lot of you guys will be familiar with this since this is a Zcash call, I suppose. But there is a cool thing called blinded RSA signatures. And this is not actually what we use, but since a lot of people are more familiar with RSA than neurocryptography, it's kind of like a simplified introduction. So in RSA, you have a server public key and a private key. And then in this protocol, we also introduce R, which is a random number, which is relatively prime to the modulus. Sorry, I switched from N to P at some point, but this should be N where it says P. Anyway, and then we have M, which is just a random token that's generated by the client, which is Brave. So the overall goal of this protocol is for Brave to prove to Brave servers that it has seen an ad or some combination of ads that are worth some amount of money without revealing to us which particular ads that they saw. And the way they do this is they take this token that they've generated, M, and then they apply this blinding factor, which is the random blinding factor R exponentiated using the public key of the server. And it sends that to the server, and then the server just does a regular RSA signature over the blinded token. So it exponentiates that blinded token to D, which is part of its private key, modulo the modulus. And then when the client gets that signed blinded token back, it can simply remove the blinding factor by multiplying by the inverse of the blinding factor. And then so you might say like, okay, what's the point of that? Like, why is this unblinded value interesting? And it's cool because if you take the property of RSA keys that R equals R to the ED mod N, and then you just substitute that in for R, then you actually find that the signature S or the value S is a signature over the unblinded token. So in effect, what happens is that the client sends a server a blinded value, the server assigns it, and then the client can unblind it and have a signature from the server over the unblinded value. So the server assigns this value, which is unlinkable to the original value that the client sent because it was blinded. But then when a client unblinds it, the client has a valid signature over the unblinded value. So then the server can check this signature, and this is an unlinkable value. So yeah, in other words, the client has a valid signature over M. The server does not actually know what M is since it signed the blinded value M prime. But later, the server the server can verify that it has signed M. So how can this be used for anonymity or privacy? So one example is, say that we want to do an anonymous voting system. Our constraints are that each client may only submit up to 5 votes, and the server should not be able to link votes that are from the same client. So each data client can generate a certain number of these tokens M, and the client, when it's logged in, can blind these tokens and send them to the signing server. Then the server can do this rate limiting step where it verifies that the client has not already claimed 5 tokens. And if that's the case, the server says, okay, you can get 5 signed tokens. So the server signs those and gives those back. But later the client can log out and then unblind those tokens. And then those unblinded tokens can be used as credentials, which are unlinkable to the original values the client sent. So then the server simply verifies that S1 is a valid signature, and then that the M1 value has never been submitted. So it hasn't been reused. And if that's the case, then the vote succeeds. As a result of all this, the server ensures each client can only get so many votes, but it does not know which votes are coming from the same client. So it's an authorized but anonymous scheme. I'm going to skip over this slide because there's a lot going on. So this is kind of like the basis of the whole Brave ads protocol, where the client periodically gets these signed tokens, and then each time it sees or clicks on an ad, it submits this confirmation token for rate limiting along with a blinded payment token. Server validates the confirmation token to make sure that they haven't seen more ads than as possible. So the point of the confirmation token is that, we want to make sure that users aren't trying to defraud us by just saying like, I've seen every possible ad, so give me like the full amount of money for that. So we kind of use that to limit that clients can only see kind of a realistic number of ads per pay period. And then they sign a payment token, which is another like same kind of like same kind of blinded token. And it collects these over a period of time, and then later unblinds the payment token and then sends that to the server with its wallet address and says, hey, so, because I have these tokens, I can prove that I've seen this number of ads and this is how much they're worth. So please give me this amount in actual BAT, which is the payment token, or sorry, not payment token, but the like actual way that the users get paid. And then the server says, okay, yeah, these tokens all valid signatures, and so this is how much balance should be in your wallet, and we'll give you that balance at the end of the month or end of the pay period. So that was like a really quick run through of how we do payments to users without being able to know exactly which ads they've seen. What else are we working on that's kind of interesting? So we have an integrated Ethereum wallet that's currently a fork of MetaMask. So we want to support Zcash at some point, even though right now it mainly supports Ethereum tokens. And so I think this is really cool because having a wallet in a browser makes it a lot easier for users who don't already have cryptocurrency wallets to be able to pay websites in cryptocurrency. So I think that opens up like a pretty interesting world of e-commerce. If you imagine a situation in which websites can assume that users have cryptocurrency wallets like right there in their browser that they can just click to make a payment. We recently announced that we're building a search engine. Can't say much more about that because it's still not launched yet, but it should be in the next few weeks. And then we're also exploring the idea of allowing users to pay for premium services such as a VPN or like an ad-free search engine experience in Brave using the same blinded token protocol. So we can basically get these payments for premium products without knowing like which user is exactly paying for them or what else they're paying for. Yeah, so that's kind of it. I don't know if I have time for questions, but feel free to email me if you have anything.
We had, yeah, and that was awesome. We had a few questions come in through the YouTube chat, but we probably only have time for one, and then we'll hand it over to our next speaker, Jay. So one of the questions was, is there a way for the user on Brave to pick their interests instead of having the browser infer the interest for them?
That's a really great question. I don't think there is currently, but that is something that is on our roadmap because, yeah, obviously for like a lot of privacy conscious users, you would probably prefer to just say what you're interested in, like what kinds of ads you want to see. And similarly, like it would be great if the browser just showed you what interest groups it inferred for you, and then you could delete them if you didn't think they were right. So yeah, that is something we've thought about.
Awesome. And then any other questions? If you want to type the answers, we can copy paste that into the YouTube channel. But for now, let's hand it over to our next speaker, Jay. I'm sharing my screen, so people should be able to see that. Jay Graber is the founder of happening.net, also Zcash alumna. So today is just the Zcash Alumni Day. And so Jay is joining us, let's see, to specifically talk about her findings on decentralized social networks. One of the things that I was really excited about was maybe like last year or 18 months ago, Twitter announced a decentralized team called Blue Sky, and their whole thing was that they were going to develop an open sourced protocol for decentralized social networks. I thought that was really cool, very much of a head scratcher. And then, but it seemed like this was a very like covert, kind of under the radar project. And then a few months later, or a few months after that, I saw that they posted an ecosystem overview or a research of all of the kind of like different approaches to decentralized ecosystem. That research was authored by Jay. And so I immediately reached out to her and asked if Jay would be interested in presenting to the Zcash community. I think it's a really great topic to complement a lot of the concepts that Jan was talking about. You know, how do we move to a digital world that allows us to be connected, that allows us to stay private when we want, and then allows for this interoperability between the different digital spaces that we want to inhabit. So that's kind of my way of introduction for Jay. I don't know if I missed anything, but please feel free to correct me or let me know if I missed anything, Jay. And then if you want to share your screen, I'm happy to hand it over to you as well.
Okay, yeah. No, that's great. Thank you, Elena. All right, let's see.
Great, we can see your screen now.
Not a second. Start at this top here. Okay. Great. So yeah, I'm going to go through an overview of the research I did for Twitter's Blue Sky project, as Lena mentioned. So far, Blue Sky as an organization doesn't officially exist yet, so I wouldn't be able to answer any questions about that. It's just mostly a group of volunteers that Twitter started talking to, and then I proposed that we write this ecosystem overview to create something during the pandemic year, which was really chaotic and not much else got done. So I'm glad that I took the time to do this because I think nobody had done like a very comprehensive overview of all the decentralized social projects out there. And this year in particular, a lot of people have started to try to build new decentralized social products. So I think having a sense of like where we've been and where we might be going is a good kind of checkpoint for that. So yeah, I'm going to just do an overview and some open questions on what I think are the important topics in this space. So first thing, I just want to start out by saying I think decentralization is a spectrum. So you have everything from very centralized sites like Twitter to very decentralized sites that are like fully peer-to-peer. And I think in my mind, it's easiest to think about the different functionality of decentralized social sites by considering some of them to be federated, the ones that are more and use like DNS and more traditional, IP addresses. And then you have the ones that are more peer-to-peer, use public keys for user addressing and might like have something that's not dependent on DNS and have every server, every client, as well as every server, like not be really differentiated because every node is essentially performing both roles in that kind of paradigm. So looking at so blockchain social networks don't really quite fall in these neat categories of is it federated or peer-to-peer, because different social networks that use blockchains may use them in various capacities, because essentially the blockchain is just a global database, but because it is logically sized, but yet it is politically and architecturally decentralized. So when you want to have some functionality that you'd really like a single database for, you want a single user or a single company controlling, this would be a great use case for potentially a blockchain in your social network. So looking at the federated protocols, yeah?
Oh, sorry for interrupting. Your audio is coming in a little bit choppy for me. It might help if you turn off your video, and that might help the audio come in a little bit clearer.
Okay, let's see. Can you still see my screen though?
Yes, screen looks great.
Okay.
Audio sounds perfect.
Great. Right, so going to this overview of federated protocols, this chart isn't super interesting for the federated ones because as you can see, there's this clear separation between the user-facing applications and then the rest of the protocol. So identity, data, networking, all that is handled like a normal website. at the server level, and then the user-facing application interfaces with that through a server-to-client protocol. And then the servers federate with each other through a server-to-server protocol. So that is true of XMPP, Matrix, Diaspora, ActivityPub, and Solid, which are all these standards that emerged for the federated protocols in this centralized social space. I included XMPP because even though it's not what we think of as social media apps, it is a chat standard that achieved very wide usage, and it was the precursor to Matrix, or Matrix models itself as a successor to XMPP. And Matrix today is being used to build applications beyond just the Discord style chat stuff it's been used for. It's being prototyped for things kind of like Twitter through Cerulean, which is a like fork of Matrix and a rough prototype of something. ActivityPub is one of the most popular decentralized social protocols because it has Mastodon built on it, which has a few million users, maybe like 1 or 2 million. Matrix has probably like 11 million or more at this point through their various interfaces for chat. And then Diaspora is kind of the defunct social protocol, but some people are still using it. And it was started as an ambitious Facebook and Twitter overhaul, like decentralized version. And then Solid is a project of Tim Berners-Lee and as well as other people, and intended to revamp the web around a more like user autonomous data model. So this chart is more illustrated for the peer-to-peer protocols, because in peer-to-peer protocols, sometimes the user-facing applications might be more connected to the identity layer that they build on top of a data networking layer, or they will separate out the identity and the networking components. And so as you can see here, the IPFS protocol ecosystem has multiple components built on top of it, which some of them support decentralized social products, some of them just serve as identity layers that are pluggable into anything else. And then at the bottom layer, there's libp2p, which is a networking stack. And so that's also true of the hypercore protocol, which has the hyperswarm networking layer, and the hyperdrives, which kind of function as identity because they have user public key associations. And then Secure Scuttlebutt is a peer-to-peer protocol designed explicitly for social networking, where every user has a public key and an append-only log through which all their posts are stored. And then you sync your posts by sharing directly with other peers one-to-one. So you will be syncing just your posts with users you're connected to and a few degrees out from that, rather than sharing all the posts in the network. Gun is a kind of a peer-to-peer database stack that has a Web of Trust application, Iris, built on it. And Aether is a peer-to-peer Reddit alternative, which has its own protocol and take the opposite approach of SSB, where instead of just connecting with your friends and then seeing their posts, you download and share everything of everyone in the network and then just prune old posts. So of all these mentioned, none of those above actually use blockchains, but there are a bunch of new social networks that use blockchains for various components. And I think new ones have emerged in the past few years. So I tried to separate these into different categories, which I think the use cases can be thought about. So under monetization, this is probably the first use case that people tried with like Steemit and these other cryptocurrency incentivized social networks where users can do payments to each other through it in cryptocurrency. And then there's also content-based incentives built in. So for example, in Steemit, you upvote, downvote posts, and then posts that are highly upvoted get like a higher allocation of the currency. And so you can actually make money posting that way. So it seems to have some adoption, but also changes the incentives of why people post. And so the quality of the posts and the nature of it is different. So it hasn't achieved as wide an adoption because people seem to be posting mainly to make money. Then you can also do titling to prove ownership on a blockchain. So I think of NFTs as essentially this. It's like an open titling system that people have been using to prove authorship and ownership of artworks, content, essays, other things like this. And essentially some of the blockchain identity systems can be thought of as NFTs or titling. So ENS, which is like a domain name or a handle that you can have a human readable name for your Ethereum address, is basically an NFT that you can trade on the Ethereum blockchain. And also there's other blockchains devoted just to identity, like Handshake protocol, And these let you like claim a domain name, or I think in some use cases down the road, possibly also like claim a unique user handle that is global and unique and yet decentralized, because we're politically decentralized because it's on a blockchain that no one party controls. Also, blockchains have been used for data storage. So essentially just using the blockchain as the database in this case. And so a bunch of applications like Peepeth, Twetch, Steemit all put their content on the blockchain. And this is kind of inefficient because you end up just storing tons of data that accumulates forever. And so without more scalable blockchains, it's probably not this idea to keep piling content on, but it's an interesting experiments have been made, including with the Zcash community. You can also use private blockchains as a private source of data storage. So the social networks like Zeek Pages and Zbay have been using Zcash to store content data and other like user data as well. I think the user identities are like Zcash shielded keys or something like that. And so that's an interesting approach to using this as like a nice like privacy layer. And also, cryptocurrency has been used as a governance tool. So, for example, this new medium-like writing platform called Mirror is using token ownership to gate participation into the community and build hype, and then probably make governance decisions in the long term. So that's something people have experimented with. Another example of this is the Steemit community, which recently forked onto a new chain called Hive. And this is because Tron acquired most of the Steemit tokens in what was kind of a hostile takeover of the chain. And so a lot of the users decided to migrate their accounts to a new blockchain. So this is an interesting example of ownership and token ownership becoming a governance tool for the whole network. So now after that kind of overview of what's out there, I want to go into some of the open questions and the areas which I kept circling back to in my research because I think there's important issues and unsolved questions here. And so those are around the topics of identity, discovery, moderation, and monetization. So for identity, in federated servers, you most commonly have a user ID that looks like Arclinia at mastodon.social. It looks a bit like email address because emails are federated protocol. And the upside of this is you have a unique human readable username and it's familiar and easy to use. The downside of this is normally you end up with a username tied to your server. And so if mastodon.social goes down, or if I want to move, it's going to be hard to get consistent linking across my new accounts. Probably they'll just do a redirect to my new account. And then if my original server goes down completely or like can't handle the scale, then I'm in trouble and basically the service is down for me. And so finding a way to do more portable identities on the federated system is, I think, one key thing to make federated networks more usable and scalable. Peer-to-peer systems have user-controlled identities because you can have a public key as your user identity. So this @3QH is actually my public key user identity and secure scuttlebutt. And then I have a human readable nickname, Arclinia, but it's not unique. So anyone else could also use that kind of a nickname. And so the upside of this is you have something that's cryptographically secure and user controlled, and that allows you to have a much more decentralized system. But the downside is now it requires user key management. And without built-in support in the browser for this stuff, I think it's quite hard. One exciting thing about stuff like MetaMask and Brave is pioneering more user key management in the browser, which might make some of this easier and abstract away this kind of like awkward key management stuff that users don't really want to deal with. Another area I think that blockchains play a potentially useful role here in identities. And so, for example, the DID standard is an emerging decentralized ID standard that's been worked on in some W3C working groups as a way to do user identities linked to public keys and other information that are human readable and global yet decentralized. And so one problem historically is how do you get blockchain, or how do you get decentralized IDs to both be pure, human, meaningful, and decentralized? And this is called Zuko's triangle after Zcash's Zuko. And the hard thing about most identity systems is you can't meaningfully get all three of these properties. Blockchain-based identities kind of get around this by cheating on the decentralized property in that you have, this fake global DB. And so this would allow you to possibly get some of these properties, and it's been experimented with as early as Namebase and some of these earlier Namebase, Namecoin and Blockstack, and some of the earlier attempts to do blockchain naming systems. Still haven't gotten huge traction, but people keep trying it because I do think it is an inherently useful direction. Discovery is one of those things that you're just really used to having in the centralized social network, because the centralized network does all the discovery and curation and recommendation for you. But in a decentralized network, discovery is often hard because content is fragmented across the network. And as I was thinking about user experiences for decentralized social networks, really finding great content is a 10x feature for any new social network. Like TikTok came along and has a great way for people to discover new content, and it becomes extremely viral and engaging because of that. And so when new products are just trying to compete on the property of decentralization, but they're actually offering a worse user experience because they don't have great discovery, that's just not going to get traction. And so one thing I've been thinking about is, how do you build a decentralized search engine, or just even a centralized search engine for some of these decentralized networks? And then what kind of recommendation algorithms can you do that surface content from across that network? So for example, in the Mastodon ecosystem, you have content fragmented across all sorts of servers, and you kind of see what users on your server are connected to. You don't have this global view into everything. And so it'd be perfectly feasible to build a global view on that and then surface some content. But then how would that interact with the rest of the ecosystem, and what would the business model be there? I think that's one of the questions. So some of the different approaches that the existing decentralized social network take, one of them is just local is better. So for example, in Pure Scuttlebutt, basically you just see content from your friends and your friends of friends. And the philosophy of the network is that's actually a healthier way to interact. You don't need to see what's going on from across the entire world all the time. But that's a very opinionated way, and it's baked in at a very deep architectural level there. And so if you want to see everything going on in the world, it's not quite possible. Then another approach is share everything. So that's the Aether approach, where every node stores all the content, but then in order to improve scalability, maybe you prune older content that hasn't been referenced in a few months. And yet another approach is using the blockchain as a global database. So that's what the blockchain social networks like Twitch and Peepeth and Steemit do. They use the blockchain as the central source of content. If you want to access that, you have to be connected to a node running the full blockchain, storing and indexing everything. And so I think probably none of these approaches are the best or final approach. Maybe having more hybrid approaches, like you have a decentralized social network where content's fragmented out, but then you have like a global crawler or indexer that provides search and recommendation. And I think maybe that hasn't emerged because the user base isn't large enough, or the business models are not there for that. So moderation is another important question in all social networks, and the ways that you do it in decentralized social networks are different. And so thinking about what are the tools available for decentralized social networks to do moderation, and can we do moderation better using these than centralized social networks? And so at the governance level, basically you have user bottom-up moderation, and then you have more community-based top-down moderation. And so the user-based is blocking upvotes and downvotes, all features that you have in regular centralized social sites. But then the community-based ones are a unique layer of moderation you can add, where for example, for each server or for each forum, you can have admins, and then you can have local governance processes for how you give power to these admins. So you can do elections or any other governance mechanism you want. And so that gives you another layer of control in between the global protocol and the user, which is just based around each community or interest group. But then when it comes to technical tooling, the question is like, what tools are available to programmatically filter content and help moderators and community admins do that task? Because in a network with lots of spam and misinformation and abuse, it's very hard for just a single community admin or even a group of them to keep up with all of that. And so thinking about some of the tools available, there is the ability to build third-party tooling and automation if you provide open APIs. And so that's something Mastodon ran into recently, which is they suddenly realized they had a huge problem with harassment when some people got harassed on one of the servers. And then the admins were unable to keep up with this and ended up just banning the user who was being harassed because they couldn't deal with it anymore. And so Mastodon started adding more third-party tooling APIs so that there's can be somebody who creates a tool for admins to just automatically delete content or automatically block users. And there's relative reputation systems, which are a form of doing moderation based on reputation scores. And the way to do that in a decentralized network kind of has to be relative because there's no one single source of truth for everyone's reputation score. And so things like web of trusts or different kinds of reputation scores, like Matrix's new playlist of reputation scores, which is just a reputation score anyone can publish to a room, and then anyone can subscribe to these and mix and match them. These are all examples of reputation systems where for a single user, there's a reputation score for every entity in the network, but that might vary from user to user. So that's one way to do filtering based on that. Like from your perspective, you just filter everything that has low reputation. Another, I think, underexplored approach is applying more machine learning solutions. And so if you look at the ecosystem of email, how it's evolved today, we have some providers like Gmail that do very advanced spam detection and filtering. And then if you sign up with, run your own email server or sign up with a small one, maybe you won't have that. And so having those solutions like Gmail, hopefully not decentralized, that come in and provide some more advanced filtering and algorithmic recommendation as well as moderation could be something very useful. One of the things to think about there is just how to do it in a way that stays decentralized and retains user privacy. And so I think it's also interesting, some of the work that Brave has been doing around like, how do you just do more things client-side and locally? So if you can do more client-side filtering and maybe only send like certain vectors to other parties, you don't need to give them all the information of the user. So then the economic incentives that can be used for moderation for the social networks that have some cryptocurrency incentive or have some payment mechanism built in, it's possible to deter bad posts by either having money deducted or by imposing some sort of energy cost on the user's device. So for example, with Aether, which doesn't have a cryptocurrency, but has a simple proof of work for each post, it's used as basically the economic deterrent is having the computer perform a computationally intensive function in order to post anything. And so this prevents
I think we may have lost Jay. Oh, she's back. Okay, great.
Oh, where did I go away?
You were talking about the block lists and allow lists.
Oh, okay, great. Yeah, so
I don't think your screen is on anymore, so you'd have to share your screen. Nice, we can see your screen now.
Great.
Look at that. Okay, quick recovery.
That's not great. Okay, I'll try to wrap up here. A few more slides, hopefully get through without more disruption.
This is fascinating though. So yeah, I know we have questions in the channel, and I think it complements really nicely with what Jan was talking about earlier. So please go ahead. Okay, I'll just try to get through here more quickly for the last few. Anyways, block list and allow list, everything tends to come down to that in the end, to when all of these other mechanisms fail. So some monetization strategies I put here. I think I was trying to categorize them in terms of selling information, processing payments, or selling namespaces. Having crypto keys in the browser and would enable a lot more of these applications. So I think the stuff Brave is working on is really exciting. The MetaMask, I kind of see it as a hack to get it into the browser through an extension. And so reputation, that's something that I think, for example, verifications that Twitter does is a service that could be sold. Advertising, of course, still might work. Subscriptions for content is an underexplored model, or like individual content micropayments for like a single piece of content. And then processing, anyone who processes payments may be able to take a transaction fee. If it's a direct peer-to-peer payment, maybe not, but perhaps there's something for the platform or the browser or like some payment mechanism there. And then selling namespaces, for example, like if you sell your Twitter handle, there is a black market for that, but it's not like an official part of Twitter. But the fact that there is a black market for it means there is demand for, you know, good custom names. And so because you sell domain names and things like this, it's clear that namespaces are a valuable symbolic resource. And so if you end up selling names as per subdomain or for the global network, that could be a potential monetization
at the protocol or server level. So yeah, I just want to leave you guys with some open questions of the stuff I've covered. Is there a decentralized identity standard that everyone can agree to use? DIDs are an emerging standard, but they don't necessarily have the widest adoption yet. So I think once that emerges, that would enable tons of new social applications. How do you discover great content in decentralized networks? I think the existing ones really focus on getting the functionality of making it decentralized, but getting the 10x feature really requires great discovery. And can decentralized communities handle moderation better at scale? Because one of the arguments for moving to decentralized social is you can give communities more freedom and autonomy to moderate and self-govern, which is great, but they need the tooling to do that. And then what are sustainable business models? Because I think everything discussed doesn't really work and gain scale traction until there are some sustainable business models powering the ecosystem. So yeah, that's my ecosystem overview. I think I've tried most of these apps. So if you want to find me at any one of these, I'm always Archelinia. Thank you.
Jay, thank you so much. The first time I saw you give that presentation, I thought it was fascinating. And the second time now that I've seen you give that presentation, I feel like I learned so much, and there's so many super relevant questions that you bring up. So I know we're right at time. I want to allow for maybe one question before we wrap up, but like some of the key takeaways that I am seeing from your presentation is one, incentive alignment on centralized systems and decentralized systems is super important. Like how you design your network, the incentives that govern your community, those often have very different ways of playing out as the community grows. And so what looks like a good incentive when you're just 4 people can maybe have unforeseen repercussions when you're scaled to 400 or 4,000. And then the Tron Mastodon case is I think a really good example of kind of like what incentives look like, what governance looks like, and just the difference between a network and a community. So the network, a lot of what you talk about is kind of the technical infrastructure that people can use, but the community is always, at the end of the day, the living, breathing humans, or maybe one day computer cyborgs that we interact with. And so kind of knowing that those are different and they behave differently is good to keep in mind when thinking about how we create like spaces to interact, social spaces on the internet. So I said I had one question. I'm going to look in the chat and see if anybody threw in a question before I steal one. Looks like we don't have any questions in the chat. A lot of thank yous, a lot of people saying great talk, Jan and Jay. So maybe my last question to you, Jay, is thinking specifically about payments on social networks. I know you mentioned them in talking about a monetization strategy, in talking about business models. How do you see something like payments evolving as networks continue to decentralize? Is it complicated? Is it a pretty easy solution? Sounds like you mentioned identity as being a primary area of focus, but I'm curious what you think about payments.
Yeah, I mean, I think for any payment thing you want to do right now, you have to kind of pick your payment infrastructure and get it set up. And so just having a more standard, web monetization model or just cryptocurrency wallets built into everything that people start using as a default could really help with a lot of use cases. So, I mean, one basic example is the fact that I still can't pay for a single article. If I want to view just one article, I usually have to subscribe. And I think that's because it's just hard and also not very economically efficient right now to do like a single transaction per user like that on the internet for like a small article or something you want to read. And so once you start being able to pay for things in a more granular way, it would be easier for me to just read that article rather than the whole subscription. And that's one business model that I think you could try even now by maybe encrypting content on a network and then like paying for the key to read it or something. But still, it's only going to be users that are crypto savvy or like have the infrastructure set up that are going to be using that until you get more general web payment or like browser payments stuff built in.
Yes, it's interesting you brought up journalism. In a previous life, I worked at a crypto journalism startup, And I'll do a quick shout out to Popula. It's a newsroom ran by Maria Bustillos, and she accepts ETH donations or micropayments for her pages, but it is arguably not a seamless user experience. Okay, well, so we are right at time. Thank you, Jan. Thank you, Jay, for joining us. And for everyone on the line, see you next month for April's Zeal call. They're always the last Tuesday of the month. And the next Zeal call, we will feature guest speakers Robin Bergeon and Ashkan Soltani, and they'll be talking about global privacy control, a standard, a web standard for protecting privacy on the internet. So thanks again for joining us, and I hope everyone has a good rest of their week.
Thank you, Lena.